Hey, Mr. Sams, what in the world is that?
That is the gigantic mole that's on the side of my head. Now, I have even a
You
bigger.
have some issues,
I have
man.
a bigger one above my ear, but it's covered in hair.
Well, that's probably good.
I didn't know I had it until I shaved my head a couple
The
years ago.
mole.
It was weird.
You know, chemistry, we like talk about moles all the time.
Moles like the moles on my head?
Yeah. Well, not really the moles on your head. It's like a little animal that burrows under the ground.
Right. Wait, chemistry mole is like the animal?
Oh, yeah, that's the other mole.
Yeah.
Oh, yeah,
That's
yeah,
what I
yeah,
mean.
yeah. But there's another mole that actually refers to something very important in chemistry.
Okay.
I wonder if we should learn about that.
Let's do that.
Okay.
Okay, so we got the little mole down in the corner there.
Yeah, Mr. Sams, there's a mole right there.
Uh-huh.
Yeah. So that mole on your face was nasty.
It's part of me, man. It's
I know.
who I am.
It's who you are.
Yeah.
Yeah. Well, you know, you could like use dry ice and freeze it off there. Actually, liquid nitrogen.
I don't think that's going to happen.
No.
No.
Okay. All right. So, folks, today we're going to talk about the mole.
Okay.
The mole in chemistry. So let's learn a little bit about the mole. So this is Vodcast 3.1. What's the mole in chemistry? So.
Okay.
All right. Let's learn about
Here
that,
we
guys.
go.
All right. Let's do it. All right. You know, chemists have a problem. Do you know that?
Well, yeah.
Probably lots of problems.
Yeah.
Especially you.
Well, yeah.
Yeah. Well, what's the problem that chemists have?
Atoms are tiny. We
Yeah.
can't see them. They're so small, but everything we do happens on the atomic level, pretty much.
So when you're studying chemistry, you've got these little tiny spheres called atoms. We learned about that in a previous podcast, but they're so tiny. So we have a very we have a problem counting them.
Yes.
Because they're so small. How do you count things that small?
1, 2, 3.
No, the problem is, one at a time, right?
Yeah, exactly.
That's how that works. Actually, if you count them one at a time,
It'll take you like bazillions of years.
yeah, so that's a problem. So how do chemists count?
Our
They
years-
don't count.
1.
No, that's
No.
wrong.
Really?
No, they don't count 1, 2, 3.
But I'm a chemist and I'm teaching my son to count, and that's...
But you're teaching them the wrong way.
Oh. How
I
should
think
I be teaching him to count?
you should count them in groups.
Oh, okay. So
One-
like I go to the store and I buy things in groups?
Right. So,
Okay.
folks, you want to do is we're going to count in groups. All right. What do I mean by counting in groups?
You tell me. I don't
Well,
know.
you see, it's like this.
Oh, okay.
Now, I know that you are a fan of Krispy Kreme donuts.
I love donuts.
Yes, you love donuts.
I do.
I'm not a big donut fan like you are, but I know that you're the donut guy.
I like donuts.
So, how do you count donuts?
1.
No,
I buy them by a dozen.
You buy them by the dozen. You buy them by the dozen. So you can't say 1 dozen, 2 dozen, 3 dozen. And so a mole is like a dozen. It's just a number that you add up as groups.
Okay.
All right. Now, if you worked at the copy room at the school, you could count is also like a, what's that represent?
It's a ream of paper.
That's a ream of paper. Now, you don't go to when you go to the copy store, do you say, I want 16 sheets of paper?
No, I buy it by the pack.
You buy it by the pack.
And there's 500 sheets in that pack.
And so the word ream actually means 500.
Okay.
And actually, we didn't write this on the previous screen, but what does the dozen mean?
There's 12 of them.
That means 12. So
And did you know that a dozen dozens is called a gross? And there's 144?
yeah.
There's another thing. All right.
A gross is another number, and that means 144.
Oh, okay. So if I order a gross of pencils, I'm going to get a package of 144.
144
So if I order
pencils.
a ream of pencils, I would get 500 pencils.
That's correct.
So if I ordered a mole of pencils, how many would I get?
Well, it's just a different number. It happens to be a pretty big number.
Okay.
Though. That number is 6.02 times 10 to the 23rd.
10 to the 23rd? That's
Yeah.
enormous.
Well, let me show you how big that is.
How big is that?
602, and then that'd be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23.
Wow.
That's a big number.
That is a huge number.
So it's just, why do we have such a big number?
Because atoms are so small.
Oh yeah, that's that problem. They're very tiny, and we learned that they're really small.
Right.
Is that right?
Smell?
Huh?
Small? What
Small.
kind of accent was that?
I don't know.
That's like part Scottish
I
this
think
time.
so.
Yeah, or maybe some
That's
French.
Australian, I think.
Are you sure?
I don't know.
Okay, who's that guy? Does he have an accent?
Well, probably so, and I'm not sure if I can do this accent. I'm not very good with this accent. But my name is Armando Avogadro.
Avogadro?
Avogadro, yes, that's my name. And
Is
you see, I came up with this number. It's called Avogadro's number.
Oh.
That's Avogadro's number. Yeah, there you go.
And that's the 6.02 times 10 to the 23
That's that number.
thing?
So that's
Cool.
it's really kind of like a famous number.
Oh, yeah.
And actually, we'd say this is the number of atoms in 1 mole.
Okay.
So that is called Avogadro's number.
Cool.
It's a big, big number.
So how many... can you help me get my head wrapped around
Yeah, so
how many
let's
things
help
are in a mole here?
Okay, well, let's think of this. If you had a mole of hockey pucks.
Okay. Wow, that's a lot of hockey pucks.
It is.
6.02 times 10 to the 23rd hockey pucks.
So if you had a mole of hockey pucks, it would have the same mass as the moon.
Wow.
I know, yeah, that's a lot of hockey pucks.
That is a lot of hockey pucks.
Yeah, the moon's pretty heavy, and so that's a lot of hockey pucks. Or another example is, let's say, well, you know, why don't we go outside and do a little clip?
Okay.
I want to do that. All right.
All right. Now, you drug me out late at night.
It's late at night.
Which I don't mind.
Yeah.
Through the pouring rain.
Yes,
I'm completely
indeed.
soaked.
You're wet.
And we've been walking for a couple of miles to take me to Lincoln Memorial.
Yes.
To
talk about the mole.
To talk about rice.
Yeah, well, we had rice for dinner tonight.
Yeah.
And so how many rice grains does it take to make a mole of rice grains?
Well, I don't know, maybe like as many as there were in my plate of rice.
No, much more than that. Much more than that.
More grains of rice to make a mole.
Yes, yeah.
If I had a mole of rice, would it be like the size of the Lincoln Memorial? This place
Well,
is big.
this place is really, really big.
It's huge.
Yeah, Abraham Lincoln's right over
So
here.
maybe like, I don't know, a couple hundred yards by a couple hundred yards by a couple hundred yards.
That, unfortunately, would be too small.
Still
it's
too
small.
small? Okay,
if you
okay.
filled the Lincoln Memorial, that's not enough.
Okay, from
that's
here...
a lot of rice grains.
All the way down to the Capitol. That's like 2 miles down
Yeah,
there.
I can see it there behind the Washington
so let's
Memorial.
say we go 2 miles that way, and then 2 miles that way, and then 2 miles up. And I filled that with rice, but I have a mole of rice.
No. Actually, that's still too small.
Cow. How far do I have to go?
Well, you'd have to actually go from here to the town of Richmond, Virginia.
It's like 120 miles.
It's 120 miles from here.
Okay.
And then go 120 miles over to West Virginia.
Okay.
And make a box that big, and then go 120 miles up to like the stratosphere, and that's
like
a mole.
beyond the stratosphere.
Yeah, actually, it's the exosphere.
Holy.
Actually.
So when I'm in a plane, I'm like 6 miles up, right?
Yeah,
so
yeah,
20
yeah.
times further than that.
Yeah. That's all right.
And fill it with rice.
Yeah.
And then I have a mole of rice.
Yeah.
That's a lot of rice.
That is a lot of rice. You see, a mole is so big because
Atoms
are small.
Okay, so 120 mile cube.
That's a big
That's
cube.
what it takes to hold a mole of rice grains.
That is correct.
That is enormous. Show me that on the map.
Okay, so
All
right now we're in Washington, D.C. doing this
Right.
podcast. And so if you were to make a box from Washington, D.C., it would be from Washington, D.C. down to Richmond, Virginia, and over to Lynchburg, and then wherever this spot is, over into West Virginia. So it would be a cube that would be 120 miles by
And then 120 miles up, which is like well into outer space.
And 120 miles up is like in the exosphere of the atmosphere, like way up here
Wow.
in space. So
That's huge.
It's huge.
That's a lot of rice.
And again, why do we have... Oh, one more thing. If you had 60 trillion body cells...
So that's about average for a person.
Yeah,
right?
so you have about
Okay.
60 trillion body cells in your body, and there's 7 billion people. How many moles of body cells are there in the world?
I have no idea.
Yeah. All right, the answer is...
I figured you'd tell me.
I knew it because it was in my head, yeah.
Yeah.
It's a half a mole.
That's it?
Yeah.
So all the people on the earth, all their body cells, there's only half a mole of body cells.
That is correct.
Now, help me get my head around this. If I had a mole of carbon atoms, how much carbon would I have?
Interestingly enough, it would be 12 grams. It would fit
That's
in the
it?
palm of your hand.
Like a handful, there's a mole of carbon atoms,
Yes.
but all the people in the world we don't even have a mole of body cells.
That is correct.
That's
Why is that?
because atoms are so small, way smaller than a cell, apparently.
Yes, and so the key thing, so why do we have such large numbers?
Because atoms are so small.
That's right. Atoms are small. And that's it for today.
Okay.
Okay, great. Bye.